to share my screen. Please tell me when you see it. Super. Yep. So here we go. Hello, everyone, and thank you so much for being here. I'm super excited to finally meet you, every one of you. So before starting with the talk, I'd like really to thank Silvio for inviting me here and for organizing this evening event. I'm really grateful to be here, joining from Italy, more precisely from Florence, and sharing my research with you all. And I also have to be honest and tell you that it's the first time I'm giving a lecture at 3 in the morning. So I think it's going to be fun. As Silvio mentioned, I am a PhD candidate at the Photographic History Research Center in Leicester, De Montfort University. And my PhD is an HRC collaborative doctoral partnership. And this means it is in collaboration with an institution that is outside the university. And in my case, is the National Science and Media Museum in Bradford, UK. So this is particularly relevant for this talk, as thanks to the collaborative doctoral partnership, I have the opportunity of researching the Talbot collections held in the National Science Media Museum, which are the largest for much concerns is photomechanical work. Here in the photo, you can see the museum, which I highly recommend visiting if you have the opportunity. And on the left-hand side, you can see some of the shelves of the Talbot photomechanical collection, which is quite impressive, if I have to be honest. This photograph was taken the first time I actually visited the collection in 2019. And as you can see, I was quite shocked. The presentation I prepared for today addresses exactly this collection, and it derives from one of the chapters of my PhD thesis, which is entirely dedicated to Talbot photomechanical work. And please tell me if I'm wrong, but I'm sure this is one of the topics that you probably have heard little about. So everything that I'm going to tell you today are work in progress ideas and the fields of research. So I would really appreciate your feedback on this work. My research for this talk starts with a very naive question. So why would a 19th century man of science, such as Talbot, that you can see here in the middle, have so many images of lace in his photographic collections? You're probably already familiar with Talbot as one of the fathers and inventors of photography, a key figure in photographic history studies for sure, especially in the UK. He was also a brilliant mathematician, a botanist, and an expert of ancient languages, with important contributions in all the above-mentioned fields and much more. Just to give you a little bit more context, 2 years before he presented for the first time his photographic process on paper at the Royal Institution, in 1837, he gave a prestigious Bakerian lecture at the Royal Society on the study of crystals, an interest he shared with Sir David Brewster and Sir John Herschel, fellow men of science and friends. So while I was expecting to find many contact prints of botanical specimens, and it would have been perfectly reasonable to find many pictures of crystals too, lace was a rather interesting subject choice, and it definitely caught my curiosity. As this picture suggests, lace was without a doubt a fascinating and beautiful subject, but what made it interesting to the eyes of a scientist? When I first approached Talbot's experimental work on photography, tracing the materials and the objects he employed helped me enormously in making something so complex, such as 19th century experimental practices, a little bit more concrete and approachable. Objects proved, in fact, to be an interesting point of connection between his scientific experimental practice and his material culture and everyday life as a Victorian aristocratic man with many privileges, as we know. For this reason, lace and gauzes became pretty soon a good case study and the leading elements of my research, and this is both due to how they look and how they perform. In fact, the underpinning argument of my research that I discussed this evening is that materials have an important agency in the development of new photographic processes. And if we follow them, perhaps they can tell a different story to the written account we conventionally follow regarding the dawn of photography and its transition to a mechanical image. The tacit knowledge resulting from hands-on experience and the consistent use of fabric materials is, in my opinion, a key element to investigate how and through what Talbot's view of photography developed. So the trigger for these thoughts have been one of the several visits I made at the National Science and Media Museum, which, as I told you, holds one of the most relevant collections of Talbot's work. During one of these visits, I came across a box, this one especially, that unlike the others of the collection, which are usually full of photographic prints, glass or metal plates, or printing books, this instead contained various ephemera. Among these, there was a set of gauze samples that resonated with the many pictures I saw before with a similar subject, such as the one you can see here on the left-hand side. Now, I'd really like to direct your attention on the exceptionality of this material, and I'm referring to the gauze. When investigating the work of a photographic pioneer, it doesn't happen that often to find objects that are not purely photographic, as it is unlikely that something ephemeral such as gauze samples are kept together with prints, let alone preserved. However, Talbot's case is an absolute exception, as he, and luckily for us, also his heirs, kept almost everything. To give you just a little taste of his exception, if we can call it like that, when he was only 8 years old, he wrote to his stepfather, and I quote, "Tell Mama and everybody I write to keep my letters and not to burn them," end of quote. He kept this attitude throughout his entire life, and today's historians are very lucky as we have an impressive variety of sources to investigate his work. The gauze samples you can see here on the right side really make me think about those ephemeral materials that are not commonly used to investigate early days of photography, even though their agency was extremely important for the development of photography. Even if the gauze samples I just showed you are in the photomechanical collection, and later you will discover why, Talbot's photographic work was not new to the use of fabric materials. In fact, we could say that objects, such as lace, saw the really beginning of photography. When Talbot presented the photogenic drawing process during the famous Friday evening lecture at the Royal Institution in January 1839, he showed a few samples of prints he made back in 1834, some of which depicting lace. These early photographic specimens were all cameraless pictures, meaning that there was no need of a camera to take the photograph. What Talbot did, in fact, was to prepare the paper with a photosensitive solution of sodium chloride and silver nitrate, put a flat and opaque object on the paper, block it under the developing frame, and place it in the sun for a certain amount of time. Now, the time depended on the weather, of course, so full time required short exposure in comparison to cloudy days that, as we know, are not always ideal for photography. When the subject was removed, what was left on the paper was an impression of the outline of the object, if shadows, if you prefer. So here in the slide, you can see the process of copying frame with the copying frames and the photograph exposed to the sunlight. And I really like this photograph as it shows how collaborative also the process was. To make a good print, and I'm talking about the cameraless contact prints, it was essential that each part of the subject was in contact with the surface of the paper. Otherwise, many details would appear fuzzy. What Talbot did, and we know this from his correspondence where he writes about this, was to wet the lace so that increasing its weight, even the finest of the thread would adhere to the paper. As soon as the English weather passed, Talbot took advantage of the longer and more intense hours of daylight to make new prints. From spring 1839 until late summer, Talbot sent several specimens of his photogenic drawing process to his scientific peers and friends, including the already mentioned Herschel, Brewster, and many more. Among these, there was the Italian botanist Antonio Bertoloni, based in Bologna. Talbot's correspondence with Bertoloni is a great example of his networking strategy to promote the application of photography in various scientific disciplines. Bertoloni kept, in fact, a careful track of all his correspondence with Talbot and preserved it along with the photogenic drawing specimens in an album called Disegni Fotogenici, which translates as photogenic drawings. So what is interesting to know is that even though Talbot and Bertoloni's common interest was botany, Talbot sent several pictures depicting lace, including lace magnified through the means of a solar microscope. Now, if we think about this, sending a parcel with a letter and a set of photographic specimens from England to Bologna, Italy, risking them to get lost along the way, as it actually happened so many times, takes commitment, and the subject selection was not the outcome of a random choice. And in fact, these pictures had a well-outlined aim in Talbot's mind. So in one of his letters, Talbot remarked to Bertoloni how the piece of magnified lace, and I quote, will be useful especially to the naturalist, since one can copy the most difficult things with much ease, for example, crystallization, tiny part of plants, etc. Then there is a gramínea and a piece of lace and another piece of crepe in their actual size to show how clearly the image is drawn, end of quote. Now, my thesis is that lace pictures, such as the one you can see here, were means to convey not just the beauty of a subject, but also the intangible qualities of photography, namely faithfulness and verisimilitude. This was a matter of great importance for Talbot, as it was not the only one that in 1839 claimed to invent a process able to reproduce any subject as nature would do without human intervention. His competitor, in fact, was Messier Daguerre and the daguerreotype process that quickly spread from France all over the world. Talbot was, in fact, in the delicate situation in which he had to provide solid proof that his process was as good as the daguerreotype and that could provide aid to observational sciences. This picture were an important element of his strategy. All the rich details that of the lace pattern were in fact neatly reproduced in the contact print photograph, displaying a degree of accuracy hard to achieve with any other subject. Furthermore, when observed with the solar microscope, lace showed a thin and regular pattern, mocking somehow crystal slatted structure, inlaying before the eyes of the viewer the proof of what photography could achieve if improvements were made. But there were also other good reasons why Talbot found in lace a good subject. If the qualities of photography were in fact abstract, lace instead, like a piece of lace, of actual lace, was something easy to believe too. By mid-19th century, lace was a material ubiquitous enough to be present in most upper class and aristocratic households, and to be visually familiar with most of Talbot's audience. To give you just an example of its popularity, when Queen Victoria married in 1840, her wedding dress was made of silk in weight and made lace, giving a decisive reboost to the English traditional lace-making industry. So people could easily check on the verisimilitude of Talbot's process, comparing a photograph with an actual piece of lace and enjoying the astonishing resemblance of the reproduction. Here is a slide, you can see how accurate the photograph reproduction was. I mean, I'm sure that if there were no caption, it would have been hard to say which one was the actual lace and which one the photograph. As he recalled in an article published in the Proceedings of the Royal Society in London, and I quote, "Upon one occasion, having made an image of a piece of lace of an elaborate pattern, I showed it to some people at the distance of a few feet, with the inquiry whether it was a good reproduction. The reply was that they were not to be so easily deceived. That was evidently no picture, but a piece of lace itself." End of quote. So Talbot used this feeling of surprise and wonder to his favor. This kind of emotional and spontaneous response was extremely important for him, as it was the most effective way to prove the realism of his process. There is evidence that it was Lady Elizabeth Fielding, Talbot's mother, the one responsible for the early photographic experiments with lace. When she saw a few photographs, probably much similar to the one that I show you, she understood the power of these images and pushed Talbot to do more of them. She used to lay a few prints on her table and to show them to her circle of powerful and influential acquaintances, realizing how these pictures could facilitate the diffusion of photography invention even to a non-scientific audience. So lace was never the subject of Talbot's scientific inquiries per se, but it became a means to investigate the potentialities of photography's application to scientific research and observation. I would also add that, in my opinion, lace pictures are precious evidence of how elements of everyday life, for instance, Talbot's mother's fondness for lace, permeated his scientific work and became a powerful tool to disseminate his invention. Talbot's hands-on experience in using lace resurfaced in a new shape a decade later, in the early 50s, when he started to work on his first photomechanical experiments, which are the main subject of my research. Usually, photomechanical processes are not a hot topic, as they are still a kind of obscure subject that often slips on the sideway of photohistory. I think that we all appreciate the wonderful reproductions that we have in books nowadays, as well as the ones that we can find in magazines and in newspapers. They are essential pieces of information in our research practice, and it is hard to think about our everyday life without them, as our own visual culture is mostly informed by them. These pictures are now made with modern analog and digital processes, such as offset photography, letterpress halftone, inkjet, electrophotography, but none of them would have been possible without the pioneering efforts of 19th century scientists and artists. These early attempts were not always successful, and it was definitely a long journey. In fact, from the announcement of photography's invention in 1839, it took more than 30 years of research to achieve successful photomechanical processes, which could be applied on a large-scale production, and more importantly, to be commercially profitable. I'm talking about processes and not a single process, because by the late 70s, there was a variety of photomechanical processes with different aims. The photogravure, for one, was, for instance, an extremely fine process, and it was mostly used for artistical productions, while on the other end, the halftone process was used for those pictures we did not need an extremely accurate degree of detail, such as the ones you can see in period newspapers. Before photomechanical processes existed, images could circulate only through original photographs, except for engravings made from photographs. This was problematic in many ways. To start with, to date, we would expect the printed images we use in our research to stay there and not to slowly fade away. In fact, this would make them a non-reliable source, and their use, for instance, in scientific environments, would be extremely limited. Unfortunately, early photographic prints on paper have the bad habit of fading, and especially when exposed to light. The chemistry that is responsible for capturing the image on the paper is also the same one responsible for destroying it. When impressed, if the prints were not washed properly, the chemicals would stay in the paper, and each exposition to light would contribute to the process of destroying the image. The issue of fading photographs was critical in the 40s, and Talbot's own publishing venture is emblematic of the issue. In fact, The Pencil of Nature, the second publication ever to be illustrated with actual prints after the incredible pioneering work of Anna Atkins, highlighted how delicate the calotype prints were, as many of them faded in the first month after they were printed. The Pencil of Nature is considered a sort of early manifesto of photography, showing the large application range of this technology in reproducing ancient manuscripts, sculptures, work of art, views of real life, and, of course, lace. The publication was really expensive, as each fascicle was illustrated with actual photographs, which had to be developed and manually applied on the page. Keeping this in mind, you may guess the disappointment of the buyers once the photographs, which were the main subject of the publication, started to deteriorate, and how much this affected the credibility of Talbot's process. I think it is also interesting to compare a calotype or photogenic drawing print and how it was translated into an engraving and circulated in magazines as ink prints, such as previously discussed. Here on the left, you can see the front page of the Magazines of Science of April 1839, reproducing three photogenic drawings, one depicting lace, a lace ribbon, and other two botanical specimens. In comparison to the calotype prints in The Pencil of Nature, ink images such as these ones prove to be more permanent, but often fail in keeping the same natural appearance and tonal gradation of the photographs they translated. However, I think that we can all agree that the lace subjects were, once again, more performative, and in respect to the botanical ones, where the leaves, for instance, appear drastically oversimplified. So, as these two examples show, the potentialities of photography applied to magazines and book illustrations were there before the eyes of many, but yet not at reach. It is in this historical context that Talbot started to work on his photomechanical experiments, which will occupy the rest of his research mind until the last days of his life, as witnessed by his son. The 1852 photographic engraving process marked Talbot's first official attempt towards ink photography. The process had the ambition to make images which would maintain the natural appearance of a photograph and, at the same time, have the performance of a print for an engraved metal plate. The objective was to provide permanent ink images and enduring cliché, able to support a high demand for prints. The main difference between a photograph and a photomechanical image lies in how they're made and in their materiality. A photograph is a chemical image, meaning it's made with chemical compounds such as silver chloride, which reacts to light, while a photomechanical reproduction is instead an ink picture. One of the first considerations easy to make is that an ink image is much more stable than a chemical one. Think, for example, about how well preserved are 19th century engravings in comparison to contemporary paper photographs. So the goal of Talbot's research was to create photomechanical images which would maintain the natural appearance of a photograph and at the same time also have the performance of a print from an engraved metal plate. In his photomechanical experiments, Talbot used an ink that was really similar to the one used in engravings, which is commonly known as printer's ink. As Talbot had no practical experience in printmaking, he borrowed ink from the skilled printer and engraver George Barclay, who assisted him in his early printing attempts. In a letter to Talbot, Barclay underlined how there were no copper plate ink makers, and that every engraver had its own recipe, perfected through years of practice and tests. And I honestly find this aspect really fascinating. Also, the metal plates were borrowed from the engraving industries, mostly steel or copper plates, and sometimes also zinc ones. So what was completely different was the chemistry used to prepare the plate and the way of impressing the image. The importance of photomechanical images is clearly represented by the over 25 years of research that Talbot devoted to experiment, looking for an effective way to translate photographic images into ink ones. I'd like to say from the very beginning that none of the processes that Talbot patented was a successful one, as the steps were often too complicated and had to be adapted case by case. This prevented it from being adapted on a large scale, and when he died, he was still working on improvements to ease the process and make it profitable. However, even if unsuccessful, I think that the experimental practice that led toward these processes can still tell us a great deal on the ways of doing photography and science in the 19th century, and also how it mixed with printmaking techniques during the 50s. Now, back to the photomechanical experiments and lathes. When in the 50s, Talbot started experimenting more consistently on a way to merge photographic chemistry with printing intaglio techniques, he adapted the same concept of natural reproduction, which informed his photographic practice, to ink images. As you can see here, his experimental research towards ink photography shows a clear commitment to maintain not only the natural appearance of the photographic image, but also a similar approach in the making of it. As a result, the two main criteria which informed this practice were the translation of delicate photographic halftones into engraving ones, and the absolute absence of retouching on the final plate. These two elements guided Talbot throughout his printing experiments, informing the choice of both the subjects to reproduce as well as the materials involved. When Talbot first started to experiment with his first ink process, the photographic engraving, he took advantage of the experience of the photogenic drawing, and many of the first prints were once again prints of botanical specimens and lathes. As early photogenic drawings and calotypes attest, these two categories of subjects were heavily investigated by Talbot. In time, botanical specimens and the far less investigated fabric patterns became key elements of Talbot's photographic practice, not only for their prospective application to scientific disciplines or commercial sectors, but mostly for their material performance in the making of the process. Regardless of differences, what they had in common was a series of material qualities which were crucial for the success of contact printing processes. They were flat, opaque objects, which could be easily found in a aristocratic or scientific environment, and placed in a copying frame without compromising the originals. It was this same set of characteristics that made these materials suitable test objects for photomechanical content printing too, initiating a long series of experiments. As fabrics and the botanical specimens proved to be suitable and successful subjects for portrait printing photography, it comes with no surprises that Talbot used them as early test objects for ink photography too. Nevertheless, unlike previous photochemical attempts, botanical specimens and fabrics did not perform in the same way. Indeed, this time, fabric materials are to become something more than just a subject. They are going to be a tool in the making of the photomechanical image. Talbot noted that reproductions of plates were much more performative than botanical ones, where the halftone areas were extremely problematic. If we look in the enlargement of the fern, we see how the ink concentrates all along the edges, and there is a great loss of detail in the center areas. On the other side, in the lace picture, each thread is well outlined, and the photomechanical image reproduces the natural appearance of the actual fabric. These images highlighted a key factor. In order to obtain detailed ink prints, the subject to reproduce needed to have a certain amount of texture, or as Talbot called it, substance, able to create neat lines which were easier to ink. As Barclay pointed out, Talbot's process was in fact closer to the aqua tint and mezzotint techniques than the engraving ones, which were notoriously more challenging to print well. In particular, the difficulty intensified in reproducing subjects with large halftone areas, such as leaves or photographs, and decreased with texturized subjects, such as lace. It was observing and practicing with these experiments that pushed him to use finer fabrics and to test the limits of the process. In the specification of the 1852 patent, Talbot theorized the use of a gauze as a grid or a screen to split the halftone areas of a photograph into smaller parts, able to retain ink. He called this the photographic veil or photographic screen. So in practice, what he did was placing a piece of folded gauze between the metal plate and the picture to reproduce, and impress it on a plate that was covered with a photosensitive gelatin, and then etch the plate, ink, and print it. As you can see, the outcome was still a flat tone, but it had texture, and the ink was no longer concentrating only on the outline. However, Talbot was not fully satisfied with the materials he used, and he kept researching for better quality and finesse of gauze. And this is the moment when the gauze samples I showed you at the beginning finally come into play. This set of gauze with unwritten text in French belonged to Talbot's correspondence with the French trader and manufacturer Jules Ferdinand Hennecart, who replied to Talbot's inquiry if he was able to provide the finest gauze. From Talbot's correspondence, we know it was again George Barclay, the engraver, who assisted him in his printing experiments, the one who pointed him in Hennecart's direction. What's curious is that Hennecart was famous and well known for trading gauze for saving flour, and their specific use is reflected by the finesse and the quality of the materials he created. In a letter that accompanied the samples, Hennecart outlined the specific quality of each type of gauze. For instance, the gauze de Paris, and I quote, is the most advanced for saving flour. It combines great delicacy and with perfect strength, since it is impossible for any of the gauzes to be stretched, end of quote. Hennecart also stressed that even if it were technically possible to make a finer gauze, there was no reason for him to produce such gauze, as this kind of product would have been useless for his business. Therefore, if Talbot wanted finer materials, as stipulated in specification, he should have invested in producing it by himself, as from the producer's perspective, there was no practical reason to invest in such product. Another option was to turn to the fashion industry, where also the gauze de Paris was employed, with the downside, however, of using more expensive materials. Both options highlighted the limits of gauze commercial use, a challenge that Talbot did not overcome. As I told you at the beginning, not all his experiments proved to be successful, and in fact, he abandoned the use of gauze ground for an aquatint one a few years later. However, his experiments with the fabric materials and the invention of the photographic veil had a great influence on photomechanical processes that followed, such as the photographic methylene and the photogravure, that is actually based on Talbot research. Even if not completely profitable, I think this aspect of his experimental practice is able to tell us a great deal on how to find creative solutions based on touch knowledge, the experience of using certain materials, in knowing how they perform. In my opinion, the photographic veil was the outcome of a consistent engagement with the materials, and it shows how a subject, such as lace and ribbons, can turn into a tool to explore the limits of a new process. So this was the main part of the research that I prepared for this evening, but as I showed you mostly experimental photographs, I thought it would have been also nice for you to see some more pictures made after Talbot's process. So the one that I showed you belonged to the first patent that was in 1852, but there was a second one later in 1858, and we have a larger variety of subjects. So the first ones were mostly cameraless pictures again, so we can see a lot of botanical specimens with different subjects. And one of the most interesting things, in my opinion, is that as this was actually, we are talking about prints and not about the photographic prints. And the thing is that there are so many copies of them. And there are also copies with slightly different variations. Like, for instance, this one, we are also very lucky because we have, and it's a rarity, the metal plate that was used as a cliché and a matrix to print it. But we have also this other reproduction, which is much better, if you ask me, that is instead now at the Met collection. And then again, other botanical specimens, and you can see how they circulated in different environments and how their institutional history is completely different. They come from all over the world because Talbot Smith, actually in the 30s, she took the collection and she spread it in so many different collections. This is why these prints are a little bit everywhere. And then later, this is instead the second patent, and with the photographic engraving process that was patented in 1852, Talbot was finally able to reproduce more complex subjects, such as photographs depicting architectures, such as here we have the Colosseum. This instead was the New Louvre in Paris, and this and also this picture actually have a much more richer history, as these prints were proofs to be published into the magazine, the Photographic News. And this was the first time ever that photographic engraving circulated in the public sphere. And then he also attempted to reproduce portraits. And one of the most interesting things, I think, to underline is that during the 50s, Talbot basically almost stopped to take photographs. So all the pictures we can see here were not made by Talbot. He took photographs that were made by other photographers and used them as text objects. Like in this case, this is a studio portrait, but it was not made by Talbot. He just took the picture and used it for his experiments. Again, here. And this instead is a pretty strange picture. I'm still pretty confused about this, but I don't know if you can see that well, but it's a collage with a lot of different artworks. And I think it belongs to one of his experiments to test photographic halftones. Here instead, we have a page of a magazine, because this was also one of his test objects. And this instead is one of the most famous pictures made with this process. And the strange rectangulars you can see here underneath the angel are actually tests again. So this is a declaration that also this image was again an experiment. And here he was testing different grounds and also different ways of treating the grounds. So some of them were etched with softer or weaker solutions. Others were heated before being printed, and so many variables, a lot. And to end with, this is perhaps one of the most famous chapters of this process. And these photographs belong to Charles Piazzi Smith and this expedition in Tenerife in the 50s. Smith was a royal astronomer for Scotland, and he went to Tenerife on an astronomical experiment. And when he was there, he started to take pictures. And he already had in mind that he wanted to illustrate his scientific report with photographs. And when he came back, he contacted Talbot, exactly asking, is there a way we can illustrate this report with photographs that are not chemical, but are ink ones? And the nice thing about these pictures is that you can see all the in-between stages that leads you to the ink image. So first, we needed to have a photographic negative. We don't have it. And then for Talbot process, it was essential that the photograph was a positive. So here we have a collodion positive. Then the collodion positive was impressed on the metal. And here, in fact, we see the steel metal with the impression. And then this was inked and will produce the final print, which is this one. And you can see that there are captions and titles. And this is because this image finally ended up in a publication. And it's just one of the few rare lucky situations in which his process could circulate, because otherwise it's a pretty unknown process. And that's it for me. Thank you.
Wow, thank you very much. Fantastic, fantastic. All right, so let's open up the floor to questions. All right, well, I have a question.
Tell me.
So far, what has been the most surprising finding, or what part of Fox Talbot's work has most surprised you while going through the collection at the Science Museum?
For sure, his creativity. Like I knew that, I mean, of course, he's a scientist and he's the inventor of photography. But what really surprised me and keeps surprising me when I go through his experimental research notes is actually to see like his trial and error phase. That is something that I think is not really present that often, at least in photographic history. Like we all very often we have this oversimplified version of processes. Like someone starts to experiment in this direction and it leads to this outcome. While instead it's so much more complex and complicated. And I just think that we are super lucky to have Talbot's collections, and they are so rich because they really show you all the in-between process and stages. Like when he starts to just have an idea and then tries to perfect it as until it actually becomes like something global. And like for instance, this thing of the photographic veil, I think is super fascinating. Like it's something that we first start to experiment just because it's a great subject, and then why not to use it as a grid that can help me to print better. So I think it's creativity for sure.
Mr. Hijorio, President Hijorio, go ahead.
Thank you, Celio. Francesca, do you know if there was ever a successful or an attempt at a commercial application of this, of basically photographing lace? I could see if, back in the middle of the 19th century, if I were a lace salesman, having photographic samples of this pattern, this quality, to be very wonderful.
Yes, that's actually a great question. And yes, Talbot was in contact with lace makers and also sellers. And again, like before photography, like all lace patterns were engraved, and it was a huge amount of work, and it was super expensive. And in fact, Talbot was in contact with lace makers, or perhaps better say like people that were making patterns for lace. And he was constantly testing if his invention would find a commercial application. But still, it was such a complex process. Like now I show you like perhaps the best photographs, but the ups and downs are like extreme. Like you can have so many proofs that are like basically almost no ink using there. So, I mean, the ideas were great. It's just that the process was really not made to be on a large scale.
I can imagine that as you went through material, there were probably some images that had possibly faded to nothing. Right,
Exactly.
very
But
faint.
it's like, it's really different in respect to chemical photographs, because for those ones, that at the very beginning of their history, they were different. Like they actually changed over time because of deterioration. While instead for the ink ones, we just know that they were as we see them, exactly in the same that when they were made. Like a bad attempt was gave the same outcome that we can see now. So it's also interesting that he kept all of them. Like there is a huge amount. You won't believe it, but this also makes me think like, what's the purpose of all these prints? Like, why do you need to keep all of them? And especially
even the failures.
All of them. And one of the most interesting things is actually about the metal plates, because okay, paper was expensive, but not that much. But the plates, like the metal ones, and I'm talking about copper and steel, that was expensive, and the material allows you to reface the plate. So like, for instance, if you make an impression that did not produce a good outcome, you can just reface it. But he didn't do that. He kept also all of them that were actually problematic, or like with scratch or things that did not work, and they're still there. And I think this is fascinating because it makes you understand how much value he was giving to failure. Actually, it's just try and error phase, and it was important to then achieve something. So it needed to be there and to stay there.
We know that early photographers who used glass negatives, if it was a failure, they would scrape off the emulsion and reuse the glass plates again and again. Oh, wow.
Exactly. And also in printmaking, like this habit of refacing, but even like there was a huge trade of engravers that would buy other engravers' prints to use them, like, just to conceal some parts and then use them as a base to make their own engraving. Like it was a huge tradition of doing this, but not for Talbot.
Fascinating. Thank you, Francesca.
You're welcome.
Francesca, he kept all his stuff, but was there some sort of written documentation that related back to those that said it didn't work because of this, or I adjusted this and got a better result? Or do you just have all the stuff but not really anything about what he was doing in the process or what he possibly changed?
Thank you. This is a great question. So it would have been fantastic to have the material as Talbot left it, but that's not the situation. And as I told you, it's niece. She took the collection and tore it apart. Basically, like there are pieces of the collection a little bit everywhere. It's true that the one in the National Science Museum is like the biggest that we have. And there are some prints, and I'm talking about the proofs that have unwritten notes. So like on the side of these prints, he writes like the etching liquid was too weak, or like the weather was not ideal, was too cloudy, or the thing. And then it's also a funny story because there is a completely different research practice behind these experiments in comparison to early photographic ones. Like for the photogenic drawing and the calotype, we know that he had notebooks, all right, where he was writing all the experiments in a chronological order. Like, a notebook is easy to keep it tidy. While instead, for these ones, he wrote on loose papers. So basically, it's crazy. I still think about why do you do that. But anyway, in the collection, so we have all these loose papers, and not always they are dated. But in these ones, he just writes the technical things that he does. Not really a lot of comments about what is working, what is not. Those information are mostly instead into the correspondence. When he's sending these pictures to his friends and fellow scientists to have feedback, he writes like what he was aiming for. For instance, the photographic halftones were like really his obsession. Like this is what he wanted to get with this process, and it was super hard because ink pictures just work differently than chemical photographs. And mostly we can get his intent from the correspondence, I would say, rather than the experimental notes, because those are really like just a record of what chemicals you use and what worked and what didn't work.
Mm-hmm. Wow.
So are you inclined to reproduce his method in any way?
I
Now that
would
you've seen so
love to.
much? No?
I would love to. Like, I had our colleague, Rostimbi, she actually made an experiment for me. And because Talbot writes that he uses black lace for his pictures. And I've been going mad because I was thinking, if it's a cameraless picture, all right, so it's just the outline. Does it matter if the lace is black or white? Like it shouldn't, isn't it? And so she made an experiment for me, like making a photogenic drawing with white and black lace. And the difference is impressive. So like, I think that this hands-on approach is actually super useful, but it's not in my plan, unfortunately, because I don't have the practical knowledge, I think, to actually make the best of it. But it would be fantastic just to see someone trying to reproduce this process, to see all the pitfalls and all the difficult parts of it.
Mm-hmm. Mm.
I'd like to invite questions from the floor. Brandon, I see your hand up. Go ahead, please.
Hey, thanks, Celio. Thanks for your presentation, Francesca. It was really interesting. Like, yeah, Talbot's photomechanical process definitely not talked about a lot. I was kind of curious about if you could talk about again the different ways. Yeah, he kind of transferred his photographs onto the metal plates, like you were talking about putting some sort of light sensitive chemistry onto the plates, and then he was placing his photogenic drawings, exposing them directly on the plates. If I'm remembering correctly from what you said.
Yes, thank you. So yes, the process was complicated, as I told you, and so what he did was first the preparation of the metal plate, and the metal plate was prepared as a normal printmaking technique. So you had to cut off the edges so they don't cut the paper, and it has to be super clean, and like nothing has to be on the plate. Otherwise, every scratch will show, of course. He was also using a gelatin, and this is also another interesting aspect of his research, because in the later part of his experiments, we are already in the 70s, he's using jello, like the same gelatin that you would eat. Like in the 70s, the gelatin was finally made commerciable, like you could actually go to buy it already ready to be used. And this is super interesting because there are these letters that he sent to his wife where he asked to buy more jello because he needs this for his experiment. Anyway, yeah, it's super fun. It's if he has to excuse himself, like I didn't eat all of them, I'm using them for my experiments. Anyway, so yes, there is this gelatin, and the gelatin is mixed with potassium bichromate, which is photosensitive. And so you prepare this layer of gelatin, and then in the first process, you will just place the flat object in contact, and then put it in the sun. It darkens what is directly hit by the sun, and the rest is not. And after you have this picture, for instance, let's say is a leaf, and then you remove the leaf, and what you have is like the darker parts are brown, and the ones that were covered by the leaf is instead pale yellow. He described this. Also, another nice thing is that he describes the colors of all the stages of these images. And the colors were super important because helped him to understand the different stages when it was ready to move on to the next one. So after he exposed this to the sun, he was washing it with salted water, and then it was ready to be etched, because basically what he had was preparing the image, but it needed to be etched, and he was preparing 3 different solutions. And this is why I tell you that this process has been a disaster. It was just impossible to make it commercial, because you can imagine that for each print you produce, you have to make 3 different etching solutions and test each one of them. Like in the specifications of the patent, he says that for each plate you need to test it, like because otherwise you would just destroy everything. So you start first with the weaker etching solution, and then if you want stronger results, you just move to the one that inserts stronger. But it was just really difficult, and also the engagement with each print, it takes so much work, isn't it? And also there's a thing that I didn't say, but Talbot, he worked uniquely on the metal plates. So the photographic part of the process is the one that involves the gelatin. All the rest is like basic printmaking stuff, like etching. And after he etched the plate, he was done. He was not doing anything further. Like he would send the plates to the engraver and printer, and it was him that was inking them and printing them. Because also the inking process was super difficult, and you needed really high technical skills to make it right. And I don't know if you've ever been in a workshop and to see someone doing this, but it's magic. Like you really have to have delicate and soft movements to make it to make the ink go everywhere, but not to stay in the white areas. So he was not doing that. It was another person that was in charge of that. And then he was getting back the print and just deciding if they were good or not.
Oh, great. Thank you. Yeah, it's interesting. Okay, so he was using like a binder, like gelatin on the plates. So you said
Yes,
1870s, right? This...
Exactly, but it was just, it was just to create a level of material that then had to be etched. Like, if, for instance, if you think about the aqua tint technique, how does it work? That you have a metal plate and then you coat it with a varnish. And then with a knife pen, you draw your drawing, all right? And then in the part that where the varnish has been removed because of the knife pen, the etching liquid goes there and etches the plate. And the gelatin had exactly the same purpose of this varnish. Like you needed to make a difference between the parts that were sand and then that didn't need to be etched, and the other ones that instead had to be etched. So it was really complex, I know.
Right. Yeah, that's interesting. It's kind of also getting, yeah, you're saying that how gelatin was starting to be like mass produced at the time. It's like 1870s, getting close to when other people were experimenting with gelatin and use in photographic.
Absolutely.
Like
and
making,
also,
gelatin silver prints or dry glass plates and things. So that's pretty interesting. Thank you.
Absolutely. And also, like one of the things that, because when I find this information, I find them super interesting, just because they are not main photographic history, but still they had such an influence on photographic history. And I also researched that before the 70s, gelatin and also gelatin desserts were considered something just for aristocrats, because it took so much time to make those gelatin dishes, and only aristocratic people or like really wealthy people could afford to have so many stuff in the kitchen to make gelatin. So it's nice that then when it gets commercialized, it changes, and it's also more approachable to be used in photographic experiments like this. But before, it was so much work.
I got some ideas going. So I can go to the supermarket, get a pack of Jello,
Exactly.
right? Get some lace,
And
right?
you're done. You're ready.
And see what I can do with that. Okay.
I'm sure you're going to have fun. Yeah.
All right. Well, thank you for a fantastic talk,
Thank
Francesca.
you.
That's wonderful.
Oh,
That's a lot of hard work. So far, I mean, you have presented a very in-depth paper. Okay, you have done a lot of hands-on research as well as a lot of secondary source research. But I'm fascinated by the idea of the letters. How frequently was the communication between Talbot and his collaborators?
it's impressive. Like it was, this is also another interesting aspect. It's just about the post system. And also, just for instance, one thing that is coming to my mind now is that the letters circulated through a different post system than the plates and the proofs. So like, yes, this is super interesting. Like plates and proofs circulate via train. So
Okay.
like they had to be sent. Anyway, that's one of those practical things that make you think about how he actually went there and asked for feedback to his fellows. So no, it was super frequent. Like even with his own wife, Constance. Like there are so many letters between the two of them, and you would ask, why would you write letters to your wife? Because they were not living together most of the time. Like Talbot was traveling a lot, and he had also an house in Scotland, and it was very often just not in Lecoq Abbey. So
All
he's
right. So
writing.
here's I'm gonna put on my paparazzi hat. And are these letters between Talbot and his wife any romantic, or are they happy to be apart?
Oh, you know, that's funny. I think that Rose will give you a much better insight because she's researching Constance. But yeah, I wouldn't describe them as romantic, to be honest. Not really. But you can see that there is love for sure.
Oh, really? Okay, well, that's wonderful.
Yeah.
All right. Okay, more questions. Please feel free to post a question to the chat box if you prefer. Otherwise, just raise your hand and we'll acknowledge you, and you may go ahead and ask your question. Oh, there we go, Clint.
Francesca, what are you up to next? What's next up for you? What are you gonna be doing?
Ah,
What you up to?
finishing the chapter. So now this was the first chapter that I wrote, and I'm kind of happy with that. And then there was an entire chapter dedicated to the attempt to publish photoglyphic engraving prints in a magazine, the Photographic News, and that's another crazy story, really. And now instead, I'm finally writing the chapter I'm most excited about. That is the one about metal plates.
Mm-hmm.
And I think that is one of those materials that are really neglected in photographic history because I don't know, even photomechanical experiments, sometimes people are asking me if it's photography or not. And yes, it is photography. And it's important to research and investigate these aspects of Talbot's work, but not just because of Talbot, because he was Talbot and he was one of the inventors of photography. It's because it was there was no division. There was not a line between what was photographic and what was printmaking. I think, especially at this
Mhm.
time with photomechanical images. So yes, I'm writing now the chapter about metal plates, and one of the collections that I'm most excited about is one in Oxford, and there is this collection of plates that are blank plate, like there is nothing on the plate. Is as if them were just coming from the plate maker,
Mm-hmm.
and he never impressed them. Like they were just there sitting, and most of them got rusty, of course. There is a lot of grime and stuff, but still they're there preserved in a museum, in a collection, and I just can't help to think why. Like, and I think that there are a lot of interesting answers to this question, and I'm going to explore them. What's the place of these materials? Like my guess, or at least the way in which I want to unpack them, is that they are material traces of this experimental practice. Even if it was not with a photographic image, that is usually what we go for. Like we go for the photographic image. What's the image? Here instead is all about the material history of making the image without the image there. So I think it's an interesting approach to explore.
Mm-hmm. Mm.
All right.
And you
Okay.
may discover a faint image.
Who
Would that be
knows?
possible? Would that be
Yes,
possible? Yeah, yeah.
yes, yes. Some of them you can see that there was something, but it's also impressive, like how much rust is on this plate. But it's
Mm.
part of their history.
Yeah.
It's important to acknowledge that.
Fascinating.
All right, we have another hand up, this time from Ian Archer. Go ahead, Ian.
Hi, Francesca. I'm really fascinated on how he started to experiment with the gauze to break down the image so it stopped the blocking of the ink, right? So you didn't lose the detail. And that's kind of how he kind of got to that point. What was there anything in your research that's kind of that light bulb moment with him that said, gee, if I put some gauze over here, I'm going to end up getting an image that photomechanically looks better?
Yes, yes, this time, yes, because as I told you, like he was really using the knowledge that he developed through contact printing with the photogenic drawing, and he just naturally tried again with the same subject. And we can see that because in those notebooks, so that not notebooks, those notes, I I spent so much time just trying to understand its order, but I think I got it. And you can see that he actually just goes back to his step. He just tries again with the botanical ones, the delays, and when he's trying with delays, you can see that immediately he recognized like how just the material pattern of lace is so performative. And then what he does is actually folding lace and the gauze and crepe. And in this way, he makes it even thinner. And there are a lot of proofs where he's just trying to superimpose the lace in different directions and to see the effect they produce. So there is a lot of research in this direction. But what is interesting, once again, is that it was not just at the light bulb moment, like this works and just going with this in this direction. He's still like trying and experimenting in other directions. Like for instance, at the same time, he was also using gum, like small particles of gum to prepare the plate and to make the same kind of texture. And in the end, in fact, that's the winning strategy that he will adopt. But still, at this time, he's thinking still that the gauze one is the better one, because what gauze did is that you just need one piece of gauze to prepare so many plates. While instead, with the gum, you have to prepare each single plate. All right. So it was something super convenient. You just have one grid and you use it on the plate and you just go. You don't need to prepare each plate in this way. And it was clever actually, but just not super performative.
Very cool.
Interesting.
All right. Jerry, do you have any questions? No? So I think you're muted.
I am. Yeah, actually, I had a lot of questions, but everybody's been asking them already. So I can begin.
Good.
All right. Excellent. Well, thank you, everyone, for coming out tonight. We are now going to engage in a little social space, so you're more than welcome to sit back, pull out your alcoholic or non-alcoholic beverages, pour yourself a stiff one,
Nice
and
cup.
relax. We're going to stop the recording now.